Integration by parts, part 2. All right. So, one of the questions that came up in class, in both my classes, after class was, can we do integration by parts instead of substitution? And so let's do a problem where substitution works really well. Let's say it's x sine of x squared. So letting u equal x squared, du would be 2x dx, and dx would be du divided by 2x. This is substitution, not integration by parts. So I would have the integral of x sine of u, dx becomes du over 2x. The x's cancel. The 2 in the denominator comes out as 1/2 integral antiderivative of sine of u du. And the antiderivative of sine of u is negative cosine of u, which is negative 1/2 cosine of x squared dx, or plus c. Works pretty simple with substitution. Would it work for integration by parts? And by parts means that we're going to split this to something we're going to take the derivative of and something we're going to take the antiderivative of. We're going to take the antiderivative of this to get this, and we're going to take the derivative of this to get this. Well, taking the antiderivative of sine of x squared is not an easy thing to do, so if I'm going to do anything, I'm probably going to put the sine of x squared here so I can take the derivative of it using the chain rule, which means I'm going to use the x dx down here, find its antiderivative, which would be 1/2 x squared. No dx when I take the antiderivative. When I take the derivative, I get the dx. The derivative of sine is cosine of what it was, times the derivative of the inside, which is 2x times dx. And of course, the integration by parts formula is uv minus the antiderivative of u prime v. We set up u v prime as the original problem, and so it's the opposite ones we put in the integral here. But u times v is 1/2 x squared sine of x squared minus the antiderivative of u prime, 2x cosine of x squared dx times 1/2 x squared. This becomes, this stays, but we have minus. Cleaning this up, the 2 and the half cancel. That's nice. But we got x squared times x to the third cosine x squared. And this is getting worse, not better than what we started. So, in general, if something works with substitution, do it. It's usually easier than the integration by parts. But some things don't. And so then you'll want to do, you'll be going into integration by parts. Now, it's possible that you might want to do some substitution and then do some integration by parts, cleaning up the messy variable first and then doing integration by parts. So it may be a combination, but not always. Now, in the preview activity, to help you see that, in the preview activity in section 5.4 of the book, they have you do a bunch of derivatives of products, like derivative of sine x. And they're having you do this so that you might understand how this integration by parts is working. So I'm going to try to show you that. So the derivative of x sine x, derivative of the first, which is 1, times the second, plus the derivative of the second times the first. So, if the derivative of this product is this, the antiderivative of this product would be just back to x sine x. And the antiderivative of this side would be the antiderivative of this sine x dx minus the antiderivative, I'm going to go plus, minus the antiderivative of negative cosine x times an x. Oh, derivative of sine was positive cosine, sorry. Positive cosine dx. Sorry, hope I didn't confuse you with that. Okay. So this, I claim, looks a lot like what this integration by parts formula is. It's the derivative of u times v is the antiderivative of u v prime plus the antiderivative of v prime u, and that's what we did here. Derivative, we did, I got it, this is the, I'm making this be the v, this the u, I've got them switched here, so derivative of v is 1 times u, v prime u, and then u prime is the cosine, v is the x. So we got this. And we could subtract this from both sides, or we could subtract this from both sides. It turns out this one's easy to do, and this one might be what we're really trying to find, the antiderivative of x cosine x dx. This is something that, if I was a problem, it's an integration by parts problem, and it becomes uv, which is x sine x, minus the antiderivative of sine of x dx. So we're trying to find the antiderivative of one part of the product rule by taking the product minus the other part, antiderivative of the other part of the product rule. And that's what's going on in this whole uv equals the antiderivative of that time subtracted from the product. Hopefully that makes a little bit of sense. And the antiderivative, just to finish this off, is the antiderivative of sine is negative cosine, which makes this be plus cosine x, and x sine x plus cosine x plus c is the antiderivative of this. Now, maybe to help you understand a little bit more, I'm going to take the derivative of this product, which is derivative of x is 1 times the sine of x. We did this already once up here, but I'm doing it again, plus the derivative of sine of x, which is negative, which is cosine, positive. I've almost made the mistake again. Cosine x times the original x. There's the product rule, creates two pieces, But the derivative of the other piece that we created is, the derivative cosine is negative sine of x, and it's used to cancel part of this product rule and leaving what we found the antiderivative of, x cosine x. And the derivative of c is 0, and so we get x cosine x. So this was the antiderivative of x cosine x. This part of the product rule, the part that we subtract, is canceling part of the product rule that we get. Of the two pieces we get, this piece cancels one of the pieces, and we get the other part, which we were trying to find the antiderivative. You may have to slow this down and go through it again and think about what I'm saying there to understand that. But that's the idea of integration by parts. Taking part of the product rule and subtracting it from the product to get the antiderivative of the other part. Okay, now there is a couple of problems I would like to do for you that use the integration by parts and have an interesting result. One of them is a place where you would think you wouldn't normally use the integration by parts, like ln of x dx. Now, maybe you should put this on your note card. The derivative of ln of x dx is 1 over x. The antiderivative of ln of x is not 1 over x. It is not. It is not. The derivative is 1 over x. The antiderivative is not. So we're going to find that antiderivative by doing integration by parts. And the first thing that usually comes to one's mind is there's not two parts. Over here we had x and a sine x that we're trying, or an x and a cos x. We could make the x go with the dx or the cosine x go with the dx, and we could do the table, but well, we're going to still do it. The u, the v. I never want to put ln down here, because then I would have to take the antiderivative, and I don't know what that is. That's what I'm trying to find out, so it would make no sense to put ln of x here, ln of x dx. So I better put ln x up here where I know how to do something with it. Take the derivative. The derivative of ln x is 1 over x dx. This is f, and this is f prime. So if I put ln x there, I must put what's left down here, which is only the dx, which is 1 dx. The antiderivative of 1 is x. So this becomes, according to the formula, uv minus v, the integral of v prime, v du prime. It's going to be uv, it's going to be x ln x minus the integral of the way we used the ln x and dx was this, so it's these two that I put in the integral here, which is 1 over x times dx. I like to put the dx at the end. Fortunately, these cancel, and all we're doing is finding the antiderivative of 1 dx, which is x. That is the antiderivative of ln x, not that. Check it. Product rule, take the derivative. Derivative of x is 1 times ln x, plus the derivative of ln x is 1 over x times x, plus oh, minus, this is minus in here. That's the derivative of ln x. Minus, the derivative of ln x is minus 1. This minus, derivative of x is 1, and that's minus. Derivative of the constant is 0. And we get 1 over x times x, 1 minus 1, and we get ln x. So the antiderivative of ln of x is x ln x minus x plus c. And this is how you get it, how you derive it. Okay. Now one that seems like it's going nowhere, but ends up working. Let's find the antiderivative of e to the x sine x dx. Doing integration by parts. So, I can take the antiderivative of sine x, I can take the antiderivative of e to the x. I can take the derivative of both of them, so it really doesn't matter which one I put in which spot. I'm going to put e to the x here, which means I'm going to put sine x dx down there. This is my v prime, and this is my u. So now I got to find u prime. The derivative of e to the x is just e to the x again, dx. The antiderivative of this v prime, this sine x dx, is negative cosine x. Notice no dx's in the functions. In the derivatives, there's dx's. So, following the formula, uv, e to the x times negative cosine x is negative e to the x cosine x minus the antiderivative of, we set it up doing this way, so we use these as the diagonal. It's minus e to the x cosine x dx minus e to the x cosine x dx, which this minus can be pulled out, this minus 1, and make that a plus, so we got plus. And if you look at this, it doesn't look a whole lot different than what we started with. The sine is just now a cosine. It feels like I'm not getting anywhere. And you may be tempted to stop and say, no, I would try something else. But I'm going to play dumb and say, nah, I'm silly. I want to just go on. I don't have any common sense, and I'm going to leave this part alone, negative e to the x cosine x plus, and I'm going to do this part, integration by parts. And so I'm going to let u be e to the x again, and I'm going to let v prime be the cosine of x dx. Almost the same, isn't it? Take the derivative here, and that's e to the x dx. Antiderivative here is sine x. So this becomes, for this thing, I'm going to put inside these brackets, it's going to be uv e to the x sine x minus the antiderivative of, we use set up this way, so we do this way, e to the x sine x dx. And guess what? We've come full circle. We started out e to the x sine x dx. We've come up with e to the x sine x dx. Have we gotten anywhere? And when I first saw this, I thought, this is dumb. And then my professor said, now think about this. It's minus on this side. We're trying to find this thing, and it's over here. It's like having an equation of x equals 5 plus 3 minus x. Why don't we just add x to both sides and get 2x's is 5 plus 3, and then divide by 2. Why not add this amount to both sides? So then I would get 2 of these on this side. I'm adding that to both sides, plus integral of e to the x sine x dx. Add on to this side, integral of e to the x sine x dx. And one of those plus another one's 2 of those integrals of e to the x sine x dx is equal to negative e to the x cosine x plus e to the x sine x. And of course there's a plus c, of course. Well, I don't want to know 2, so I'm going to multiply everything by a half. And I get the antiderivative of e to the x sine x dx, what I wanted to find out in the first place, is half of this plus half of this. Now let's check it. Is this really the antiderivative of e to the x sine x? Let's check by taking the derivative. There's a product. I'll hold the half, the negative 1/2 on the outside and do the product rule. Derivative of e to the x is e to the x times derivative of the first times the second, plus the derivative of the second, derivative of cosine, is negative sine x times e to the x, plus 1/2, again a product rule. Derivative of e to the x is e to the x sine x, and the derivative of the second is, derivative of sine is cosine x times the first. And the derivative of c is 0. So we got negative 1/2 times e to the x cosine x and plus 1/2 times e to the x cosine x. So those two are going to cancel. And then I got negative 1/2 times the negative sine of x e to the x, which is plus 1/2 e to the x sine x. And we got plus another half of e to the x sine x. So a half plus a half is a whole e to the x sine x. So what seemed like I was going to go into an endless circle turned out not to be such a bad thing, because this ended up being minus. I was able to add it on to here and then divide by 2 and get the antiderivative of e to the x sine x, which is right there is where we had it. We took the derivative of this and we got e to the x sine x. This cyclical thing happens occasionally. It's not very common. It's more common to be doing integration by parts like on x to the third sine x dx, and letting u be the x to the third, putting the sine x dx here, and taking the derivative, and we get some stuff that has x squared cosine x's or something like this, and then we have to do it again to become x to the first, and then do it again to get rid of that x so that we can finally do it. It's common to have to do repeated integration by parts to get something like that to eventually drop in power until it's gone. It's not very often to get the cyclical thing going on here. Okay? That's my second shot at integration by parts.